Refraction is the bending of waves when waves move from one medium to another. When a wave hits a new medium, it changes speed and then wavelength changes. When it goes from air to water, it slows down. When light waves from the sun pass through a droplet of water in the air, the light is refracted. The different colors of light travel through different speed through the drops of water. Therefore, the colors are refracted, and you have what's called a rainbow. How do waves behave when they have no medians in between them? Well, actually, you get to see whatever's there because they are reflected.
Okay, we're going to talk about refraction. There's several things going on here. You know that light travels in a straight line at the speed of light. And if it hits a object, it bounces back. You see the object. If it hits a shiny surface, it bounces back. You see yourself like in a mirror. But if it hits like right here, you see the blue, red, and green laser. So it's hitting that surface, it's bouncing back, and you see that. Anything you don't see, the other colors that you don't see, they've been absorbed, okay? Interesting enough, if the light hits a prism, if the light is going to hit a prism, it's going to bend the light. So look at this white screen here. The light is hitting the prism, and it's bending the light. So now you see the light here, as well as over there. So you do see it in both places. It's bending the light. See how it's bending the light? And you see it there because light travels from air through this thick plastic transmitting surface, and it bends as it goes from one medium, air, to a solid. See how it's bending? Okay, here, where you have the laser, notice the laser pointing directly here, in the laser. If I put the prism there, and I turn it, look, there's the prism now pointing at the white board there. So notice the laser can move, can bend when you're using a prism, right? Also, I want you to draw your attention to what happens when you use a hand lens. See the hand lens? Light still travels in a straight line, and the hand lens will, actually what will happen is it will transmit through it because it's translucent. But you can kind of see a difference here with another point there, all right? So it does transmit. The same with a clear, see there's a clear marble. It's transmitting, going through the marble this way, still transmitting, going through the marble. Okay, I want to try a test tube with water, still transmitting, going through the water, and I wanted to try different forms of lenses, and this time I'm going to try them with this. See, it is transmitting. This is called a convex lens. It's thick on both sides. See, and it's transmitting, but it's short. These are lenses that look at how they transmit. They transmit the color of the lens of the laser short. Notice how it's short. And the reason these lenses are used to measure the focal point of your vision, this is what happens. Notice how it gets smaller, then it's getting bigger. This is what happens when they're determining the lens that they're going to use for your glasses to see far-sighted or nearsighted. Also, there's a concave lens that does the same thing. So right now, we looked at all these different types of prisms and lenses, and what you need to remember for a prism, it refracts the light and it bends it. So the light of the laser pointing in That is the light of incidence, and the light of refraction is how it bends. So if you look right here, notice how it's bending the light as I move this along. Now I'm going to give you a little light so you can see a little bit of more light so that you can see. But here you have all the lasers pointing, including this one. I put the prism there. It refracts going from one medium to another, and it's bending the light. I put the prism here, and it's doing the same thing. Here it's going straight, bouncing off, because this is reflection, this is refraction, okay? And it has to do with the speed of the wave. Refraction.